Welcome. In this video tutorial, we are going to build a simple IoT system to control an LED light connected to a microcontroller from a web application. For this tutorial, I am going to use the ESP8266 microcontroller dev board, the Arduino ESP8266 libraries, the Angular framework, and a Raspberry Pi. We begin by implementing the code to program the ESP8266 dev board. I am going to use Visual Studio Code and the Arduino plugin, but you can use the Arduino IDE if preferred. First, let's write the configuration to connect the microcontroller to a Wi-Fi network. For this, we need to include the ESP8266 Wi-Fi header. If you need help adding the Arduino ESP8266 libraries, check the link in the description to learn how to add the required Arduino libraries. Next, we need to enable the GPIO that is going to control the LED light. I am going to use GPIO 5. Lastly, we are going to implement a REST API to handle GET requests from the web application. To do this, we need to include the ESP8266 web server header. Let's compile the code and upload the program to the board. To test Wi-Fi connection, you can go to the serial monitor and start monitoring your board. You may need to restart your board to initiate a new connection. Now that we have finished programming the microcontroller, we can start wiring the circuit. Using a female to male wire, connect one end to the D1 pin, which is referenced to GPIO 5, and the other end to the LED. I will use a 150 ohm resistor, and I am going to connect it in between the LED and ground. Use another wire to connect the ground pin to the resistor to close the circuit. Next in this tutorial, we're going to develop a web application using the Angular framework. We begin by starting a new Angular project. With the following command, we'll generate a new project. Select Yes, select CSS. You can see your new project being generated in real time. If you get the following error, you can go to the generated project, open the package.json file, find the module that is complaining for, which in this case is the Jasmine core, and change it to 3.8. Save the file, change directory to the generated project, and install using Node. This may take a while. Now that your Angular project is generated, you can test by entering the following command. To see your web application, go to the browser and type localhost 4200. We are going to modify this template to build up our web application to control the LED light connected in the microcontroller. Let's open the project in Visual Studio Code. Let's begin by implementing the service to call the microcontroller API. I wrote a blog with step-by-step instructions for this tutorial. Go to the link in the description, scroll down to the Angular development part, and copy the code implementation.
In Visual Studio Code, create a new file in the app folder. Call it data.service.ts and paste the code here. After that, save the file. Next, using the Angular CLI, we're going to generate a new component. The following command will generate an Angular component. You can see the new generated component in the apps folder. We're going to be modifying these files. We'll begin by modifying the led.component.ts file. Go to the tutorial and copy the code. Save the file. Next, we'll modify the HTML file. Lastly, the CSS file. We need to make a few more modifications to the project. Open the app.component.html file and delete everything. Go to the tutorial and copy the following HTML script. Paste it and save the file. Next, go to the app routing.module.ts file. Copy the code implementation and paste it and save the file. Finally, go to the app.module.ts file and copy the following code implementation. Paste it and save the file. Now go to the browser and you should see your new UI interface. To test communication from your web application to your microcontroller, connect your microcontroller to your laptop to power on. Start monitoring and toggle the button. To conclude this tutorial, we're going to deploy web application to the Raspberry Pi. For this, you're going to need to SSH into your Raspberry Pi. SSH into your Raspberry Pi. Update the Raspberry Pi. Next, upgrade the Raspberry Pi. After your Pi is updated, go ahead and install Apache server. Once the Apache server is installed, let's explore some of the default files installed by the Apache server. This is the default web page by the Apache server. Go to your browser and type your Pi's IP address, and you should see the default web page by the Apache server. Let's delete the template HTML file provided by Apache server. If you refresh the page, you should not see anything now. Next, we're going to build the Angular application deployment package. The following Angular command will generate the necessary artifacts needed for the web application deployment. You will see the generated artifacts in a folder named dist, revealed in File Explorer. Go into the dist folder and create a zipped folder of the LED controller artifact. Next, we're going to transfer the zip file to the Raspberry Pi using scp command. We're going to place the zip file into the Raspberry Pi's home directory. You should see the zip file. Unzip the zip file. Copy all the files in the LED controller folder into the var www.html folder. You will need root permissions. Once you copy all the files, go back to the browser and test the web application. You can see that your web app was successfully deployed into the Raspberry Pi. Now try accessing the web app using your smartphone to toggle the LED button connected to the microcontroller. Congratulations, you have successfully completed this tutorial. If you liked this tutorial, don't forget to like and subscribe. For any future IoT projects, visit my blog and subscribe to my email list. You will be notified for any new IoT projects uploaded to my blog. Thanks for watching.